So today we're going to dive into a pretty fascinating piece of research that's proposing a groundbreaking new way for AIs to handle just massive amounts of information. It's called recursive language models. And honestly, it might just be the key to giving AI something it's never had, a truly perfect memory.
All right, let's just get right into it with a kind of surprising truth. That super powerful AI you use every day, for coding, for writing emails, whatever it is, well, it has a shockingly bad memory. I mean, we've all seen this happen, right? You're in the middle of a long conversation and it just completely forgets key details from just a few messages back. And this isn't some minor bug we're talking about. It's a really fundamental limitation.
So the fancy technical term for this whole problem is the context window. And what that really is, it's just the amount of information an AI can hold in its attention at any single moment. I love this analogy they use. Think of it like a chef's cutting board. If that board is way too small, you can't possibly prep all the ingredients for a big, complex recipe all at once. You're constantly having to swap things in and out, and you're probably going to forget what you've already chopped. Well, that is exactly what's happening inside the minds of even our best AIs today.
And the direct result of this tiny cutting board, it's a phenomenon researchers are calling context rot. And it's a really simple but brutal rule. The more information you try to cram into an AI's prompt, the worse it's going to perform. Its ability to reason, it literally just starts to decay.
And this isn't just a theory. Take a look at this. The graph here shows a top-tier model, GPT-5, being put through its paces. Now, on the simple stuff, performance is fine. But look what happens when it's faced with more complex problems, things that require it to connect a bunch of different dots. The scores just fall off a cliff. I mean, from nearly perfect all the way down to basically zero. This is context rot in action, and it is a massive, massive problem.
All right, so that brings us to section 1, a radical new approach. This is all about thinking outside the box. So, the authors of this paper, they propose a really fundamental shift in how we think about this. They say, look, instead of trying to stuff the entire cookbook inside the AI's tiny little memory, what if we just treated the cookbook as an external environment that the AI can interact with?
And this brings us right back to our chef analogy, because it just brilliantly shows the difference. The standard AI, that's our poor chef with a tiny cutting board, totally struggling to manage everything at once. But the recursive language model, the RLM, that's a chef with a full pantry. They don't need to hold every single ingredient in their hands. They can just walk over to the shelf and grab exactly what they need, right when they need it. And this diagram right here shows exactly how that's possible. Now look closely at this. The entire long prompt, let's just say it's an entire novel, it's not being fed directly into the language model. No. Instead, it gets loaded as a variable into a coding environment. The AI actually sits outside of this environment, and it writes code to peek into the novel, to slice it up, and to analyze it piece by piece. It can even call on other AIs to help it out.
Okay, section 2, how it actually works. And the key idea here is the AI as a programmer.
So the whole thing really breaks down into 4 main steps. First up, the entire text, the whole novel, gets loaded into a coding sandbox. Step 2, the AI writes its own code to search and slice that text up into smaller, manageable chunks. Third, and this right here is the recursive part, it actually calls a copy of itself, like a little sub-AI, to go analyze just one of those chunks. And then finally, it writes more code to take all the answers from all those little subcalls and stitch them together into one single coherent response.
And when you see this in practice, it is really fascinating. The AI isn't reading the whole text at once, not at all. It's acting more like a detective. It literally writes a program to scan this massive document, looking for specific clues, specific keywords, and it pulls out only the most relevant snippets to work with.
Okay, so once it has those snippets, it then breaks down the main problem. It writes another piece of code that basically says, all right, sub-AI number 1, you go analyze this batch of text. Sub-AI number 2, you take this other batch. It's basically delegating the work out to a whole team of little specialists.
And then in the final step, it's like the project manager. It takes all the reports back from its little team and it programmatically stitches them all together. And what's amazing is that this method lets it build an answer that's not just more accurate, but it can be way more detailed than anything it could ever have generated in a single go.
All right, so that's the theory. But the big question is, does it actually work? Section 3, putting RLMs to the test. And let me tell you, the results are pretty stunning.
Okay, so this is the moment of truth. On the left, you see that original graph again, that standard GPT-5, just totally failing as the prompt gets longer. But now look at the right. That is the RLM-powered version of the exact same model. The performance, it stays rock solid, even as the input text balloons to 1,000,000 tokens and even more. It doesn't suffer from context rot. The difference is absolutely staggering.
Let's put some hard numbers to this. So, on a relatively simple task, the RLM gives a nice little boost in performance. But look at the really hard task. The base model scored 0.1%. That's a complete and total failure. The RLM-powered version, it scores 58%. I mean, that's not just an improvement. That is a transformation from literally impossible to totally achievable.
58%. Seriously, let's just let that sink in for a second. We're talking about the difference between an AI that is completely useless on a complex problem and one that is genuinely helpful. This is the breakthrough.
Now, I know what you're thinking. This sounds amazing, but it has to be crazy expensive to run, right? And surprisingly, no. Because it's so smart about how it works, the median cost for an RLM run can actually be cheaper than a standard API call. It's just not wasting time and money chewing on irrelevant information. That little program it writes filters the context down to only what really matters.
So what does this all mean for the future? That brings us to Section 4. The future is recursive, and what this really means for AI.
So, what are the big takeaways from this huge leap forward? Well, first, we're talking about handling inputs that are up to 100 times larger than what's possible right now. I mean, think about feeding it an entire codebase or years and years of financial records. Second, this really is a whole new paradigm. AIs aren't just text processors anymore. They're becoming agents that can actively go out and explore a data environment. Third, this isn't some proprietary trick locked away somewhere. It's a scaffold that you can basically wrap around many different existing models to give them this superpower. And finally, and this is maybe the most exciting part, this opens the door to training AIs from the very beginning to think this way, right out of the box, which would make them even more powerful.
And the researchers themselves, they see this as a completely new way to make AI more powerful. For years, the way we've scaled AI is just by making the models bigger and feeding them more data. But this paper, it suggests that teaching them to think recursively is a powerful new axis of scale. It's not just about getting bigger anymore, it's about getting smarter.
Which, it leaves us with a really provocative question. Just imagine an AI that could read and perfectly recall every single medical study ever published to help diagnose a rare disease, or analyze the entire human genome to find a cure. Or what about comprehending a company's entire financial history in seconds to prevent fraud? What kinds of problems could we solve if an AI's memory was truly, truly limitless? This research suggests we might actually be about